Hello, here we are. Welcome. We are going to talk about how to generate the equation of a line from a point tester. And let's pretend our point tester was in the form y equals 2x. So convention would have it that we're going to go ahead and have discussions about slope and y-intercepts and rates of change. I'd like to take a step back away from that if we could, and just to talk about some possible points that might work and what this really means, this idea of y equals 2x. The y is twice the input. So if I had an in-out chart, xy, and I chose an input like, I don't know, say 1. This statement up here again implies that the y value is twice the x. So if x is 1, my hope is that you know y is 2. We can also talk about substitution here also. 2 times that input of 1 should give me the output of 2. So we can get several different values here. Make x 2. Well, 2 times 2 ultimately is 4. Y is twice the x. Make x negative 2. We should get negative 4. Now the question always comes, now what? Well, now you've done the hard work. Plot your points. And you can see your point 1, 2 is going to match with this guy. 2, 4 is going to match with this guy. Negative 2, negative 4 should match with this guy. What does it look like? The hope is we recognize it's collinear. They're all sharing a line. So we could draw a line that passes through these. I'm going to use my line tool here. A line that passes through. Again, we're looking for all points that satisfy this relationship. Let's look at another one. Let's say the point tester was y equals 1/5 x. Well, this is a little tougher. Fractions tend to intimidate us a bit. So one of the things we discussed in class is the idea of what would be some good inputs to choose. 1/5 of what? Well, how about 1/5 of 5? That's 1/5 of 5. Well, that answer is 1. How about 1/5 of, I don't know, 0? Still 0. How about 1/5 of 10? 2. Again, we're generating points from this equation. These points all fit and satisfy this equation. That's the intent here. 5, 1, 0, 0, 10, 2. Can we make a projection as to what's going to happen here at negative 5? Either from the graph or the numerical analysis, the hope is negative 5, negative 1. Back to that line tool. Connect the dots, and we've got our equation of our line. More importantly, again to me, is the idea that you recognize this point 5, 1 also satisfies this equation and is also on this line. That's where this is coming from. Okay? So that is a foolproof way to generate the equation of a line, generate the graph of a line from an equation.